Good morning and welcome to a lesson all about crossing and concurrency. So what are we talking about here? Well, this is an equation of a line. Let's call that line number 1. This is an equation of a line. Let's call that line number 2. And this is an equation of a line. Let's call that line number 3. So if these two lines meet each other somewhere, we would say that they cross. So we're going to find out maybe the coordinates of the point that they cross based on the algebra of these equations here. If all three lines happen to meet somewhere, then the word we use now is concurrent. So if those two lines cross, and it just so happens that the third one crosses at exactly the same place, then we would say that they're concurrent. If the third one misses, then they are not concurrent and we'll have this triangle going on instead. So second half of today all about triangles. But right now, we're going to find out where lines cross, whether they cross, and whether they are concurrent, whether three or more meet at the same point. Just note that if I concur with you, then I agree with you. So this rule here is satisfied by all the points where 2 times the x number plus 5 times the y number, take away 14, gives you the answer 0. So there's a whole load of points that concur with that rule, that agree with that rule. And if there's a point that agrees with all three of these rules, then you would say that is the point of concurrency. That is the point where all three of these lines concur and agree. Now, of course, that's very unlikely in real life. By random chance, if two lines are like this, if I can draw another line anywhere in the whole universe, it has a probability literally of 0 of actually meeting them. But in exam questions, the probability is quite a lot higher because they seem to find it quite fun, just like me. Okay, so line number 1, line number 2. Do they meet and where do they meet? So just to get an idea, I mean, for starters, these could all be the same line in disguise. So let's just get an idea. Let's just do a wee sketch and see what's going on. So we're going to have some axes. We're going to have x and y axes. That's good. This line, number 3, is quite easy to sketch because it's got a y-intercept of 6 and a gradient of 2/3. So remember, it looks like y equals mx plus c, where m is the gradient is 2/3, the slope, and c is 6 is the y-intercept. So I can go ahead and put a 6 on there, gradient 2/3. So line 3 looks something a bit like this. Line 2, that's a wee bit harder to plot. One way of doing it, remember, this looks like y minus b equals mx minus a. So I can say for a fact that this line just so happens to be satisfied by the point where x is minus 5 and y is minus 2. So x minus a being x plus 5 means a must be minus 5, so minus 5 makes plus. So this point is on that line, x is minus 5, y is minus 2, that's somewhere here. It has a gradient of 3, so it goes up something like that. Sorry, number 6. That is line number 2. If I wanted to find out its y-intercept, well, that is the point when x is 0, remember from last time. So I could put that in here, and I've got y plus 2. If I go, forget that for now. At the point when x equals 0, I've got y plus 2 is 3 lots of 5. So y plus 2 is 15, which means that y is going to equal 13. So up here, that's a y-intercept of 13, which kind of makes sense on my sketch. Great. Sketching line number 1. Let's just mess around with it to make it look like y equals mx plus c, because that's the easiest way, really. So add 14 both sides, subtract 2x both sides, and I've got 5y equals minus 2x plus 14. Divide by 5 both sides, and it's important here to make sure you do it properly. So I'm dividing the whole thing by 5. So one way is to write it out like this to make it really obvious, because what's going to happen now is I need to divide that bit by 5 and that bit by 5. So I've got y equals minus 2 over 5x plus 14 over 5. So gradient minus 2/5 going downhill gradually. Y-intercept of just under 3. So let's go and put that on here. A y-intercept of about 3, so here, that's 14 over 5, going downhill gradually, like that. So that's line number 1. And it looks like they might just meet, or they might just miss. It's only a sketch, I can't be sure. So let's find out properly, accurately, using some algebra. Okay, so if I want to know where two lines meet, I need to know where they concur, where both rules are true. Every point on this line satisfies this rule. Every point on this line satisfies this rule, and so on and so forth. So what I'm going to do, just to make my life simpler, is I'm going to start with this and simplify it a bit. Okay, so let's leave that out for now. I'm going to take off 2 off both sides and expand the brackets. So I'm going to have y equals 3 times x is 3x, 3 times 5 is 15, take away the 2 is 3x plus 13. So this line is satisfied by every point that satisfies that rule. These are the points that are on this line. If there's a point, well, we know there's a point where these two cross now because I sketched it. So to find where they cross, that rule is satisfied and that rule is satisfied. In other words, 3x plus 13 has to be equal to the y coordinate, and the y coordinate has to be equal to 2/3 x plus 6. That one has to be equal to that one, has to be equal to that one. So all we're doing, we're solving these two equations simultaneously to find the point where they are both true at the same time, simultaneously. Okay? And the easy way of doing it in this case is I can make it look like that. There are lots of other methods for solving simultaneous equations. So, let's just get that y out the middle. I've got 3x plus 13 is the same thing as 2/3 x plus 6. Why don't I go ahead and subtract 6 off both sides and subtract, no, let's not do that. Let's subtract 13 off both sides and subtract 2/3 x off both sides. So here what I'm going to be left with is 2 1/3 x equals minus 7. So subtract 13 from 6 and you get minus 7. Subtract 2/3 from 3 and you get 2 1/3, which is ugly, by the way. So let's just convert that properly. So 2 whole ones is the same as 6/3. So I'm going to have 7/3 x is going to be minus 7. So why don't I times by that 3 both sides and divide by 7 both sides, and I'm going to get x is going to equal minus 3. So 7 divided by 3 times minus 3 gives you minus 7. Right, x coordinate of the place where the lines cross. So to find out the y coordinate of the place where the lines cross, I can basically choose this or this or this or this, and actually it's kind of sensible to check with the one right back where you started, because in case otherwise you've made an error somewhere. So I'm going to go check that this gives me the same y coordinate in both equations, because if it does, then the place agrees with both equations and the lines must cross. So this equation right where I started, so I haven't, just to check whether I made any errors here, I've got y plus 2 equals 3 lots of, here we go, y plus 2 is 3 lots of x plus 5, but x is minus 3, so minus 3 plus 5. And here, using this equation here, which is the original form, I've got y, it should be 2/3 of minus 3 plus 6. So just putting minus 3 into here. Okay, so here, y plus 2 is going to be the same thing as minus 9 plus 15. Work that all out. So minus 9 plus 15 is 6, plus 2 is going to be 8. So y equals 8. Work that out over here. Y is going to be 2/3 of minus 3. Minus 9 plus 15 is 6. Take away 2 is 4. 2/3 of minus 3, that is going to be minus 2, plus 6 is going to be 4. Okay, excellent. So I have the coordinates x equals minus 3, y equals 4, in other words written better as minus 3, 4, and this point is on line number 2 and line number 3 from back up here because it satisfies both of these. We've just checked that. Out of interest, on my sketch, minus 3, 4 is quite a good candidate for this kind of location here, so that makes sense as well. Okay, so to check whether this line number 1, also goes through the point minus 3, 4, so minus 3, 4, is that there? I can just put those numbers straight into this line here and find out whether it works. Again, it's probably best to work with the original form just in case I made a mistake anywhere. So let's check. I'm going to check the point minus 3, 4. Is that on this line as well? Well, I've got 2 lots of, just make sure you can see that, 2 lots of minus 3 plus 5 lots of 4 minus 14 equals 0. Let's see. So minus 6 plus 20 minus 14. That does indeed equal 0. So you could say, and we have to conclude if we're going to try and prove that they are concurrent. So we could say a little sentence, say lines 2 and 3, because I labelled them, which was very useful of me. Lines 2 and 3 cross at minus 3, 4, and minus 3, 4 also lies on line 1. Therefore, so these 3 dots mean therefore, and it's just a slightly quicker way of making my life easier. Therefore, 1, 2, and 3 lines are all concurrent. And you could say, if you wanted, at the point minus 3, 4. Great.